My name is Ricardo Bessa. I'm from INESC TEC. I'm the coordinator of the AI4LREANET project, which is an European project that started in October 2023. And we have been applying AI for critical infrastructures. The project is not just focused on energy, it's going to other infrastructures, and it is a fully open source project. So all the results from the project will be published in open source, and parts of the project are already going to Linux Foundation. So just in a glance, just to show you the project and objectives. So this is about reinforcement learning. Actually, we started doing this before the Gen AI wave. So somehow reinforcement learning is now forgotten inside the LLM, but it's still a very critical component on AI. Of course, we also address here supervised learning, but the core of the project is reinforcement learning, and it's very focused on reinforcement learning, distributed and hierarchical one, because scalability is one barrier in critical infrastructures when you want to apply in real networks, not just power grids, but also rail, oil, and traffic management. Scalability is one issue, and explainability is another one, because we have humans in the loop, so we have to interact with humans. And that's why the project is very focused also on the interaction between AI and human, and different modes of interaction considering the use cases. So this is just human-centric AI, but it's also how you optimize the whole system. The agents of AI, the human, even the traditional tools or conventional tools, they exist in control rooms. So it's also using digital environments to test AI, develop AI, and even train AI in synthetic data and then deploy in real-world cases. As I mentioned, it's not just power grid, it's also rail and air traffic management, and all have open source digital environments. So you can see more results on our perspective paper where we show our research approach. This is some other conceptual framework. As I said, this is human-centric AI, so there is a strong emphasis also on the human part and the human agent, so we are not replacing humans. The idea is to combine the benefits of still having a human in the loop and an AI. And in the middle, we have this human-machine interface, which is super important, how you can design human-machine interfaces for this human-centric AI, and this is also a focus on the project. For the environment, as I mentioned, we have these environments with baselines, with synthetic data generation. One of the environments is grid-to-op, which is now a LFE energy project. So the project is actively contributing to grid-to-op. So grid-to-op is also part of this project. You'll see some open source results that are related with grid-to-op. There are baselines, and there is this interactive AI, which is on the top of grid-to-op, another environment that is exactly what makes the link between the human and the AI. I will show an example on that for the power grid. And as I mentioned, this is a full open source project, so there are already results in our GitHub page. We also created actually a GitHub page so that you can better see what other repositories we have in the project GitHub. You have the QR code, so feel free to see what is there, and we are looking for contributors. So I will show you some of the results. They are already open source in the GitHub, and they are centered on the power grid. So one is distributed reinforcement learning. So this is a work of Politecnico di Milano. And what they are doing, they are dividing the network in sub-areas, and each sub-area will have a reinforcement learning agent, and they are coordinating between each other. The goal on the project is to have one agent per asset. So one agent for a line, one agent for a generator, even one agent for a switcher if you want to change the topology of the network, and then you have to orchestrate all those agents with distributed and potentially hierarchical reinforcement learning. So that's one work. As I mentioned, the code is already in the GitHub. Another one is on predicting the behavior or the failure behavior of an AI agent. And this is super critical because we know agents, AI agents, sometimes they give wrong recommendations. And the first time you give a wrong recommendation to a human operator, the trust will decrease. And then it will decrease more and more and more, and then no one is using the AI agent. So one way is trying to predict when a failure can occur ahead of time, so it tells, for example, you can predict five steps before a failure occurring, then you communicate to the human that you are not able to solve, if a congestion occur in that line or in that area of the network, you cannot provide a recommendation with high confidence to solve that problem. And this gives human time to make studies and try to solve the problem with other tools, or even with his own mental model, with this experience to do. So this means that AI can also inform the human when there is low confidence in what is providing as a recommendation. This is one important requirement, not just to engage the human, but also with the AI Act from the European Union. So that's one thing, is also a resource you can find in open source. Another one is a graph neural solver. So we are seeing these foundational models for power flow calculations. There is GridFM project. Another approach is to use this physics-informed machine learning to be a proxy of a power flow calculation, but they need to be physics informed. So they need to guarantee that the laws of physics, the power flow equations, they are respected. So the graph neural solver was developed, is also in open source, exactly with this in mind, to have this as a very fast AC power flow. And this is something has been working in. Power flow is a critical function on power grid operation. So that's one result. Another one is this interactive AI, and this is, it started, the concept is the hypervision concept that was first developed by RTE to Power Grid. It's actually also a Linux Foundation project operated fabric, where there is this hypervision concept, and this is somehow an adaptation of the concept to human AI interaction. So there are some similarities in terms of concept, but the design, it's a little bit different. So on one side you have the alerts, so the human is managing the grid, looking at the alerts, and there is a timeline for these alerts. Then you have the context, where they can see what is happening on the grid, and then you have the recommendations of the AI that the human can accept or not. You can even modify those recommendations, providing feedback to the AI model. And the idea is to have a unified interface where you have the operating context of the grid and the alarms, and at the same time you have the recommendations of AI. So what we are trying to build here is unified interface between AI and humans, with interoperability in mind, because this interface is not just being made for the power grid, it's being made for other critical infrastructures. And as I mentioned, and to conclude somehow my presentation, the project have a cross-sector application and a cross-sector dimension. And this is very important, because there are a lot of lessons that we learn by talking with other infrastructures, with railway, with air traffic management, the way they operate. Some of them are more advanced in the use of AI than the power grid. Air traffic is one of them, so they are much more advanced, even in terms of standards. And then there are problems that are quite similar. I put here this example. So Flatland is an open source environment similar to Grid2Op, but in this case for railway. And the problem they have is automatic train redispatch and rescheduling, which I hope works well, because my train tomorrow was cancelled. So cancelling trains is actually one option on this model. And I think in Germany it doesn't count to the delay statistics. So. And so this is where reinforcement learning can also be used for train rescheduling. Not, of course, to do a very mission-critical task in the railway, but this is very similar to redispatch in the power grid. So there is a lot to learn also from these infrastructures, and this cross-sector collaboration is quite strong and quite important. Okay, so, and just to conclude, so we are open to collaboration with open source community. We are trying to bring the project to LF Europe, and then we have to see if we do it in LF Energy or in another one like AI and data. But the goal is to, and we have this objective of building a community around this. In the consortium, we have industrial partners like RTE, TENET in the power grid, SVB and DB on railway, and NAV Portugal in air traffic. But there is also a lot of academic institutions and SMEs. So we are open to collaboration. Feel free to contact me. You have also the website of the project. Is very easy to find, and you can contact us. Okay, so it was a light talk, 10 minutes. So if you have any questions, I will be around today and we can talk. Okay, thank you.